Okay, so we can start the lecture now. So we will begin with general systems of equations. Okay, so let's say we have three variables, x, y, and z. Okay, so we can come up with a bunch of equations involving x, y, and z. For example, sine x plus y minus z squared equals 1. X squared plus y squared plus z squared is equal to minus 1. And let's say x e to the y plus z is equal to 0, for example. So we've got three equations and three unknowns. Okay, so you know from grade 10, 11, and 12 that the way that you solve these is with simultaneous equations, right? So for example, in grade 12, you had two equations with x and y. You would take equation 1, substitute it into equation 2, maybe solve for x, then substitute x and then solve for y. So normally you would solve simultaneously. Okay, so technically it's possible to do that here. You can solve this simultaneously, but that's very difficult. The reason is these are non-linear equations. We can see here we've got sine x. That's a non-linear function, right? It's not a straight line function with x, so that's non-linear. This z squared, that's non-linear. X squared, y squared, z squared, that's also non-linear. And this x e to the y, that's also non-linear. So it makes it very difficult to solve. So what we're going to do is not look at these non-linear equations and instead look at linear equations. So linear equations in x, y, z. Okay, so these are just equations involving x, y, z, where x, y, and z are multiplied by some constant. So we can have a1x plus b1y plus c1z, let's say is equal to k1. a2x plus b2y plus c2z is equal to k2. a3x plus b3y plus c3z is equal to k3. So you see that all of the x, y, and z terms are linear. Okay, you're just multiplying them by some constants. Okay, so this is what we mean by linear. Okay, so here we have three linear equations. Okay, with three unknowns. Okay, now again, you could solve this using simultaneous equations. So equation 1, you would solve for x, substitute it into equation 2, and then use equation 2 and 3 to solve simultaneously for like y and z. Okay, but that's a bit complicated to do. Okay, because you have to keep track of what you're substituting into what. So we're going to be learning a new technique to solve these that is much easier. Okay, so instead of simultaneous equations, we're going to come up with a new technique. Okay, so let's have a look at a first example just to illustrate what this technique is. So let's say we have x plus 3y is equal to 1. And then we have x plus y is equal to 2. Okay, so here we have two linear equations with two unknowns. Okay, so we'll see later on what happens if we have too few equations or too many equations, but the number of variables for our cases will be either 2 or 3. Okay, later on we'll look at 4 variables, but for now just 2 or 3. Okay, so how can we go about solving this? So in high school, you would say you have equation 1, you solve for x, substitute it into equation 2, and then solve. What we're going to do is treat these equations as if they were objects by themselves. So in other words, we're going to take equation 1 and equation 2, and we can add them, we can subtract them, and so on. Okay, we're going to treat them as like one thing. So let's take this equation 1 and equation 2, and let's subtract them. Okay, so what do I mean by subtracting them? I mean, I'm going to take the x from the top equation and subtract the x from the bottom equation. So x minus x, that's going to give me 0. Next, 3y minus y, that's going to be 2y. And 1 minus 2, that's going to be minus 1. Okay, so I've got 2y equals minus 1. So y is equal to minus 1/2. Okay, so by subtracting the two equations, we get rid of x and we can solve for y. So let's make a little note of what we did. Okay, so we subtracted the two, we got rid of x. And so we could solve for y. Okay, good. Now that we have y, we could substitute back and then solve for x. But we're going to try use this method of adding and subtracting equations to cancel things out. So instead of substituting back, let's see if we could add or subtract these equations to then get rid of y. So in the first equation, we have 3y. In the second equation, we just have y. So if we add or subtract them, it's not going to cancel the y terms. However, if we multiply equation 2 by 3, then we are going to get 3y. So let's do that. So let's multiply equation 2 by 3. Okay, so what do we get in that case? So we have x plus 3y is equal to 1. And for the other equation, we had x plus y equals 2. But now we're going to multiply the second equation by 3. Okay, as long as we multiply 3 on both sides, then there's no problem, right? If you do it to the left-hand side and the right-hand side, you haven't changed the equation. So here we're going to get x plus 3y is equal to 1. And if we multiply the second equation by 3, we're going to get 3x plus 3y is equal to 6. Okay, so I've just multiplied everything together. I've just multiplied everything by 3. Now we see that the first equation has 3y. The second equation has 3y. Remember, we're trying to get rid of the y term, so now we can just subtract the two equations. So we subtract them. And what do we get? We're going to get x minus 3x. That's going to be minus 2x. 3y minus 3y, that's going to be 0. And 1 minus 6, that's going to be minus 5. Okay, so we get minus 2x is equal to minus 5. So 2x is equal to 5. So x is equal to 5 over 2. Okay, so we get our two solutions. We have y is equal to minus 1/2 and x is 5 over 2. So x equals 5 over 2 and y is equal to minus 1/2. Okay. Are there any questions so far about this new method? Okay, so it's not too bad so far. Okay, let's have a look at another example. Okay, so just what you should keep in mind is if we have systems of equations, we can add or subtract the equations like we've done here, and we can also multiply equations by constants. Okay, so let's just make a little note. So number one, we can add or subtract equations. And number two, we can multiply equations by constants. Okay, so one more thing we can add to this list. I hope you agree with me that if we swap these two equations, nothing's going to change. So we've got equation 1 and equation 2. If we swap the labels, in other words, we put this one first and then this one second. So we get x plus y is equal to 2 and x plus 3y is equal to 1. We haven't changed anything, right? So I've just swapped the labels for which one's equation 1 and which one's equation 2. Nothing's actually changed that much. Okay, so we'll see why that's important soon. So let's just add it here. So number 3, we can swap equations. Okay, so these are like the beginning rules for this new method that we're developing. Okay, so let's have a look at another example. So let's say we have 2x plus 3y is equal to 1, and x minus y is equal to 2. Okay, so again, two linear equations, two unknowns. So what we want to try and do is use these rules, the adding and subtracting, multiplying by constants and swapping, to try and turn this into something like x equals something, y equals something. We want to solve for x and y. So we want to manipulate these equations such that we get our solutions at the end, like we did over here with these examples. You see, we manipulated the equations, we added them together, we multiplied by constants, and we got our two solutions. Okay, so that's what we want to do. Okay, so in the first equation, we have 2x plus 3y equals 1. In the second equation, we've got x minus y equals 2. What we really want is the first equation to be something like x equals our answer for x. And the second equation, we want y equals, and then our answer for y. In other words, the coefficient of x here should be 1. Currently, the coefficient here is 2. So what we could do is divide the first equation by 2. That would give us our coefficient of 1. Or we see that the second equation already has a coefficient of 1. So a better thing to do would be to swap them. Okay, so now I'm going to call the second one equation 1 and the first one equation 2. So we have x minus y is equal to 2. 2x plus 3y is equal to 1. Okay, I hope that makes sense. If you do have any questions, please just shout out while we're going through this. Okay, good. Now the coefficient here is 1, which is what we wanted. Now in the second equation, we have this 2x term. Okay, let's just highlight that. We've got this 2x. If we look back at what we really want, remember this on the right-hand side, this is what we want. We see that the second equation doesn't have any x terms. It only has y. But what we have here is 2x. Okay, that's not going to work. So what we can do is take equation 2 and subtract 2 times equation 1. Because then that 2x and the 2x will then cancel. So we're going to take equation 2 and subtract 2 times equation 1. Okay, is anyone confused by that statement? Okay, cool. So we're going to have x minus y is equal to 2. And now equation 2 minus 2 times equation 1. So just imagine that there's a 2 times in front here. So 2x minus 2x, that's going to be a 0. 3y minus 2y, because remember there's the 2 minus signs there now. So it's going to be 3 minus 2, so it's 3 plus 2, that's going to be plus 5. And we're going to have 1 minus 4, so that's going to be minus 3. Okay, and this is our new equation 1 and equation 2. Okay, everyone all right with that?
Sir?
Yep.
May you please repeat the last part?
Okay, sure. So we're taking equation 2. Taking equation 2 and subtracting 2 times equation 1. So what we have here is this 2x and then minus 2x if we look over here. So let's just write that on the side here. So it's going to be 2x, sorry, let's just write it above here. So it'll be 2x minus 2x from here. Then we're going to have 3y, this bit here, minus 2y. Okay, that's from, actually, let's just distribute the 2. So if we distribute the 2, it's going to be there, there, and then that's going to become a 4. And lastly, we're going to have 1 minus 4. So that's 0. That's 5y. And that's minus 3. Okay, so you can imagine looking at this in terms of columns, so like that, if you want to. So for the x part, we're taking 2x minus 2x from above. That gives us 0. 3y minus 2y, so that's 5y. And then 1 minus 4, so that's minus 3. Okay, is that all right?
Yes, I thank you.
Okay, awesome. Okay, so we see that in equation 2, we have y being multiplied by 5. That's our new thing that we need to worry about. So if we look back at what we want, that's this bit. What we want the first equation to be x equals the answer for x, and we want the second equation to be y equals and then the answer for y. Currently, we have 5y equals minus 3. What we want is y equals something. So let's do that. Let's divide equation 2 by 5. then that means y is then by itself. So we're going to get x minus y is equal to 2. And then we're going to have 0. Let's just keep the 0 for now. Plus y is equal to minus 3 over 5. Okay, so I have just divided equation 2 by 5. So we can say equation 2 divide by 5. Okay, and if we ignore the 0, that is exactly what we wanted our second equation to be. We wanted it to be y equals the solution for y. Now, the first equation, we want that to be x equals and then the solution for x. So what can we do to get rid of this minus y? Because we want x equals something. So this minus y, that needs to go away. What can we do? Any ideas? Okay, so we know the rules. We can add the two equations, we can subtract the two equations, and we can multiply and divide by constants. So what can we do with these two equations to get rid of that minus y in equation 1? Okay, any ideas?
I think we can subtract equation 2 from 1 because we already have y, so that we can get x.
Great, but this is a minus y. That's a minus y and that's a plus y. So we won't subtract them, we can add them because the minus y and the plus y will cancel. Do you see that?
Yes, I can see that. Thank you.
Okay, cool. Okay, so let's add the two equations. So we're going to add equation 2 to equation 1. Okay, so let's do that. So x plus 0, that's just going to be x. Minus y plus y, that's going to be 0. And then 2 minus 3 over 5. Okay, that's going to be, so we can write that 2 minus 3 over 5. That's going to be 7 over 5. Okay, that's our new equation 1. And our equation 2 will be 0 plus y is equal to minus 3 over 5. Now, if we just get rid of those zeros, this means x is equal to 7 over 5 and y is equal to minus 3 over 5, which is exactly what we wanted. We wanted to solve for x and y. Okay. So I hope you see like the beginning of this method. So let's just go through this again. So we started off with these two equations and we just looked at what we wanted. We wanted the first equation to be x equals something and the second equation to be y equals something. And we have these three rules that we can do, or the three operations that we can do. We can add or subtract equations, we can multiply or divide by constants, and we can swap equations. So since the first equation needs to be x equals something, we swapped the two equations so that the x was at the top. Okay. Then what we need, so over here, we need in the second equation, we need y to be by itself. Okay, we don't want any x terms. So what we do is we subtract the two equations after multiplying the second one by 2, and then that gives us y by itself if we divide by 5 after that. Then in the first equation, we want x by itself. So we add equation 2, and that gets rid of the y. Okay, and that gives us x by itself. And then after all of that, we have two equations where the first one is x by itself, and the second one is y by itself. Okay, so let's just rewrite the operations that we can do and have a look at another example. So allowed operations. So number one, let's say we can swap equations. Number two, we can multiply/divide equations by a constant. Okay, and number three, we can add or subtract equations. Okay, so these are the operations that we are allowed to do. Okay, I hope that makes some sense now. Okay, so let's look at another example. Let's say we have minus 2x plus y is equal to 0, and we have 3x minus y is equal to minus 1. Okay, so remember what we want. We want x by itself in the first equation, and we want y by itself in the second equation. Okay. And we want y by itself in the second equation. Okay. In other words, for the second equation, we want to eliminate x. And in the first equation, we want to eliminate y. Okay, then that will give us x equals something and y equals something for equations 1 and 2. So that's 1 and that's 2. Okay, so what can we do to these two equations to get x by itself? Or we just want a single x term. So you see in equation 1, we've got minus 2x. In equation 2, we've got 3x. What can we do so that we only get x out at the end?
We can add the equation.
Yeah, exactly. So let's add equation 2 to equation 1. Okay, so if I add them, remember I add the x terms, I add the y terms, and then I add the constants. So minus 2x plus 3x, that's going to be x. Plus y minus y, that's 0. 0 plus minus 1, that's going to be minus 1. And the second equation, that stays the same. We haven't done anything to that. Okay, so we've got ourselves equation 1 and we've got ourselves equation 2. Okay, good. So we've got x by itself inside equation 1, which is what we wanted. Now for equation 2, we want to eliminate x. So what can we do with these two equations to get rid of that 3x? Okay, any ideas? Just remember the rules. We've got these three things that we can do.
I think we're going to multiply equation 1 by 3.
Yeah. good. And then, yeah, that's the first step. And then what's the second step to get rid of it in equation 2? Subtract. Yeah, good. You got it. So we are going to take the second equation. So take equation 2 and subtract 3 times equation 1, because then we have 3x minus 3x. Okay, so let's do that. So we're going to have x plus 0 is equal to minus 1. And now we're going to take equation 2 and minus 3 times equation 1. So just imagine that there's a 3 times in front of everything. So 3x minus 3x, that's going to be 0. Minus y minus 0, that's going to be minus y. And minus 1 minus 3, so that's minus 1 plus 3, that's going to be 2. Okay. So is everyone okay with that? So we took equation 2 and we subtracted 3 times equation 1. And we get these 2 new equations. Okay, so let's get rid of those zeros. So we get x is equal to minus 1, minus y is equal to 2. Now for, that's equation 1 and 2. But we don't want minus y, we want y. So let's multiply through by minus 1. So we get x is equal to minus 1 and y is equal to minus 2. Okay, so you see that using those 3 operations, we can solve for x and y. Okay, so I think that's enough for today. On the Learn 2022, I'll post the link to the new WhatsApp group. Okay, so I need to make a new WhatsApp group for Math196 and my other class that I'm doing. So I'll post the link and then you can join. And then I will post on the WhatsApp group today's homework. Okay, so it will be very similar questions to this here. And then tomorrow we will finalize this method and then look at the row operations and row echelon form of augmented matrices. Okay, so that's the next section that we're going to be looking at. Okay, as always, if you have any questions, please post it on the WhatsApp group, or you can send me an email. Okay, so I'll see all of you tomorrow.
Sir.
Okay, bye everyone.
Sir,
Yeah.
do the homework questions still have bonus marks?
Oh, yeah, of course.
All right.
Yeah, same as last semester.
All right.
Cool. Bye everyone.